Good morning, everyone. Welcome to Monash University here at Clayton. I'm Professor Joanna Batstone, the Director of the Monash Data Futures Institute, and I have the privilege of being your Master of Ceremonies today. I've also had the pleasure of serving on the Scientific Advisory Council for Fleet over the last few years, so it's great to be here today hosting this event. Before we begin our official proceedings, I wish to acknowledge the people of the Kulin Nations, on whose land we are gathered here today, and I pay my respects to their elders, past and present. The ARC Centre of Excellence in Future Low Energy Electronics, FLEET, was funded in 2017 and was officially launched at this very same location here in the New Horizons building in June 2018. Our guests here today include current members, alumni, collaborators, and stakeholders, and each one of you has had a significant role in FLEET over its 7-year journey. The Centre of Excellence is a collaborative research program that brings together leading researchers from different disciplines and institutions to study research topics or challenges. And FLEET's mission has been to reduce the energy used in electronics for computing sustainability. The Centre's objectives are to gain global recognition and advance knowledge, to foster collaboration, to advance knowledge, to partner with national and global centers for competitiveness, attract top researchers and talent to build capacity, provide quality training for the next generation of researchers, support tackling large-scale problems, and establish hubs and linkages within the wider society. Through collaborative efforts and groundbreaking research, the Centre has made substantial contributions to scientific progress and the advancement of electronic technologies. FLEET's impact extends way beyond the laboratory, changing the culture of STEM research and education, sharpening the focus on information technology sustainability, and training tomorrow's innovators. It's my pleasure now to introduce the director of FLEET, Professor Michael Feurer. Michael is a pioneer in the study of electronic properties of two-dimensional materials and has extensive experience establishing and managing large interdisciplinary research teams like this one in both Australia and the United States. Michael and his FLEET colleagues will now lead a presentation on FLEET's impact and legacy, highlighting key achievements across 6 impact areas: knowledge, sustainability, capacity, STEM education, innovation, and leadership. Thank you for joining us today, and over to you, Michael.
So I'm going to try to tell you about what 200 people did over 7 years in 10 minutes. So as Joanna said, FLEET's mission is to reduce the energy that's used in computing and create a sustainable future for information technology. So I'll try to unpack that a little bit just in a couple of minutes and tell you a little bit more about what that means. Some of you probably don't know too much about what FLEET does, so I'll try to explain what we're trying to do. So the background is that all of the computing that we do, so essentially all of the devices that we use to do wonderful things with information, rely on the basic unit of those computations is a transistor. So a transistor is a solid state switch. It uses a voltage applied to one electrode to either allow a current to pass between 2 other electrodes or to turn that current off, to block that current. So it has an on state and an off state controlled by a voltage. Okay, so it's a little switch. The thing is, we're very good at making these switches. We can make them, we can mass produce them. So what you see here on the left is an image of a silicon wafer, which contains microprocessors, and those microprocessors, there are 800 microprocessors on this 300 millimeter wafer. Each one of those microprocessors contains 1.4 billion transistors. So on that wafer, about 1 trillion transistors just on that one wafer. And those are coming out of the fab, the factory that makes them, quite rapidly, right? So we're very good at making these transistors. We can make lots of them, and then we can do really powerful tasks with information with those transistors. So the technology that is used to make those transistors is called silicon CMOS. It doesn't really matter too much what it's called, but it's been in place for about 50 years, since the late 70s. And the reason that we have used this one technology for all of that time is that at that time, in the late 70s, it was realized that if we made transistors with this technology, they were okay then, but we could, every year we had a plan for how to make them a little bit better. We could make them a little bit smaller, slightly lower voltage, pack more of them onto a chip, and they'd be a little bit more energy efficient, and they would also run faster. And so every year we had this plan to make this transistors a little bit smaller, a little bit cheaper, a little bit faster, and a little bit more energy efficient. And that turned out to be really great. There's this roadmap for improving things year by year, and it worked fantastically well. So on the right, what you see is the growth in computing capacity around the globe. And this chart covers about 2 decades, but really this growth happened over about 4 decades. Computing capacity grew at about 60% per year, which is just astounding, right? Nothing grows at 60% a year for more than a couple of years, right? So 4 decades of growth at 60% per year, which is really amazing. And that technology allowed us to build 10 to the 22 transistors by today. So that's 10,000 trillion transistors. Wikipedia tells me there's 10 to the 18 grains of sand on Earth. So it's many more transistors than there are grains of sand on Earth. It's obviously by far the most of anything that has been built by mankind, humankind. So this is the thing that we are really good at doing. Humans are essentially the transistor making ape. This is what we do. We make transistors and we use them. But this technology that we've used to make all of these transistors, which has been fantastic, is really kind of running out of steam. We're unable to keep making it slightly smaller and slightly faster and slightly more energy efficient every year, and that is having a cost. So the cost is that every year this increase in computing capacity means that we're using more energy to do computing. And so the energy that is used in computation is shown here in the green line, and that is rapidly moving towards the yellow line, which is the world's energy production. Currently, computing uses about 10% of the world's electricity, but you can easily extrapolate to computing to use all of the world's energy, electricity, and not within a couple of decades. And so one of two things will happen. If we stay on the current course, computing will be strongly limited by energy production, and that will be a very finite resource. The amount of computing we can do will be limited by the amount of energy that we can produce. So we would like to be able to do more computing. We'd like to be able to do greater things with computers. So computers make every other industry more energy efficient. So it's a good thing that we have this resource. We would like to use computers to better model climate change and understand what's happening. We'd like to use computers to understand how proteins fold to make a virus, and how that virus structure determines how the virus infects. We'd like to use computers to design better drugs that have fewer side effects, right? So there are things that we want to use very complex computing capacity for, and so we want that resource. And it's a good thing. So this is where Fleet comes in. Fleet is looking at how to make a better transistor that switches at lower voltage and uses lower energy. And it's that basic unit of computing. So it's really going back to the drawing board, the very fundamentals, and trying to redesign that transistor. I'm going to try to tell you a little bit about how that's gone over the last 7 years. I'm going to tell you three little vignettes, little stories about things that Fleet has done related to that mission to give you a bit of a flavor of that. First, I'm going to talk about this concept of a topological transistor. This is something that Fleet proposed in 2016. There are new materials called topological insulators that are insulating in their bulk. They don't conduct in the interior of the material, but they conduct on their boundaries. And so if they're two-dimensional, if they're very thin, they conduct along their edges. And they can conduct perfectly along those edges without resistance or without any dissipation that would turn electricity into heat. We proposed that topology could be switched on and off with an electric field. So we could apply a voltage, and that would switch the material from this topological insulator with these fantastic conducting edges to a regular insulator, which is insulating off. It doesn't carry current. And so that would be the basis of a transistor. It's a radical idea. It had never been done, and it was something that we proposed as a major part of the center. And by the end of 2018, we had actually demonstrated that in a particular material, sodium-3 bismuth, we could accomplish this switching. We could switch that material from a topological insulator to a conventional insulator, on and off. And so that was fantastic. We went on to then show that the topological insulator, these topological materials, due to strong spin-orbit coupling, actually had an advantage over CMOS, that they could switch at lower voltages. And then we've gone on to show other designs for devices which we think really could be very competitive with CMOS. So now this concept is on the semiconductor roadmap, the international roadmap for devices and systems, the IRDS, as a promising beyond CMOS device technology. And there's a spin-off company that has that's been formed to license this technology that was developed in Fleet and develop it further. So we also had a vision of using a very different kind of particle to do computing. So this is a thing called an exciton polariton. It's a bit complicated, but it's the quantum mechanical entanglement of a particle of light, a photon, and matter, or electrons. And in particular, it's an electron that has been excited in a semiconductor and leaves behind a hole, and that electron binds to that hole, which is positively charged. The electron's negatively charged. It forms an exciton, and then that exciton can then have this very strong interaction with the photon and form this entangled half light, half matter particle. That gives it some very unusual properties. This fact that it's made up of light and made up of matter. And in one property in particular is that you can form superfluids out of these exciton polaritons, and they can flow without resistance. So that's again, this flow without resistance is something that we thought is very promising for making a device that uses low energy. So the challenge here was that this resistanceless flow had actually been observed, but at very, very low temperatures, essentially 4 Kelvin, very near absolute zero. And so what we wanted to do within Fleet is bring that up to room temperature. We thought any useful device, anything that's going to be in your phone or on your desktop, is going to be at room temperature. And so we need this to work at room temperature. How do we do that? So we decided to look at using atomically thin semiconductors, new materials of just a few atoms thick, where we could make these excitons. They'd be strongly bound at room temperature, and they would work at room temperature. And so we did that. It was a big engineering challenge. It was interdisciplinary work. It involved people that knew the materials, people that knew how to make these photonic cavities, people that knew how to study them with lasers, ultra-fast lasers. And so it requires this big center-sized effort to bring all those people together to do it. And we did it. We were able to make these excitons, these strongly interacting particles, at room temperature in 2D semiconductors and observe their behavior. We did not get them to condense into a superfluid, which would have been really fantastic. That's like a room temperature superconductor. but as you know, room temperature superconductors are pretty difficult. But we did observe some really cool behavior in these excitons and 2D semiconductors at room temperature. So this is a picture. It's a bit of a complicated picture, but essentially it's a snapshot of what these excitons are doing, not in real space, but in momentum space. And so left and right are basically means that they're either heading to the left or heading to the right. And these collections of excitons, these bright spots, you can see are either all on the left or they're all on the right. They're not down in the bottom of this curve. And that's a behavior that you would just never, ever, ever see in electrons in a semiconductor. That basically they all are collectively moving to the left, all together in a big herd. And that's something that just wouldn't happen in a semiconductor, but it's happening with these exciton polaritons, and it's happening at room temperature, and they're maintaining this very coherent behavior, and they're doing it over really large distances. It's tens of microns, but that's large on this kind of device scale. And so really interesting behavior that's going on in these new kinds of particles, and it's happening at room temperature. Lastly, I want to tell you about a discovery that's actually kind of serendipitous. You may have gotten the point that a lot of the science that Fleet is doing is underpinned by two-dimensional materials that are just a few atoms thick. So we were very interested in how we could make more of these two-dimensional materials. They're a bit difficult to make. And Fleet had this fantastic center where we brought together chemical engineers and people with expertise in electronics and material scientists. And as it turned out, some of our scientists were very interested in the properties of liquid metals, and particularly the chemistry that happened on their surface, and discovered that you can use the surface of a liquid metal as this really fantastic reaction vessel to make two-dimensional materials on the surface. And it's a self-limiting process. They grow, and then that's it. You get one layer and it stops. And so turns out that that's just fantastically efficient to make lots and lots of two-dimensional materials. We immediately use this to make a kind of gallium oxide glass coating that helped us protect our 2D semiconductors and allowed that work that you saw on the previous slide. And so we applied that to the work that Fleet was doing. But it turns out it's useful for doing things like carbon capture, catalysis. You can make filters out of these 2D materials. So there's lots of other applications. And that all came out of the fact that, well, we needed 2D materials, and we also happened to have this interest in liquid metals. And and it's really cool stuff. There's also a spin-off company that's pursuing this research. So that's kind of the thing that happens when you put together a bunch of people that are really good at what they do, and you task them with some kind of new problem. Okay. Lastly, I don't want to drown you in KPIs at all, but I want to point out a little bit, just maybe one little story, one sort of quantitative story about the outputs of the center. We started off, you put 200 researchers together and you give them some funding, and they're going to produce scientific outputs. That's like sort of a given. We wanted outputs that were impactful, right? And so we picked a KPI that we thought was ambitious. We want 20% of our papers to be high impact, right? So things that are really important, those important papers. One out of 5 papers, that would be really fantastic, right? So as it turned out, we were able to have over half of our papers, over half of the papers that Fleet produced during its run, were high impact papers. They were in high impact venues. And that was just really fantastic. It's something that was unexpected. We didn't dream that we could have half of the papers be that, have that level of impact. But this is what happens when you bring people together and you task them with something that's a very important problem. You give them the resources, the time scale to work on that problem, to work together, and they can produce things that really matter. And that is the thing that I think centers can do, right? And this shows it that yes, of course we produce papers, but half of them, more than half of them, were in high impact venues, and I think that's really fantastic. Okay, I probably took more time than I was supposed to. I'm going to, what you're going to hear is several stories about Fleet, not just the knowledge creation that I've told you about, but some of the other aspects of what Fleet has done over the years. Next, I'm going to hand to Kiralee Rule, who's going to tell us about capacity building and what we've done there.
Thank you, Michael. So what you just saw on that last slide was a little bit about our scientific outputs. But scientific outputs in terms of patents and publications is not all that we were at Fleet. So at Fleet, we understood that it was important to invest time and resourcing into building Australia's scientific capacity. So that is nurturing future leaders through training, mentoring, expanding research capabilities, expertise, and through networking. Certainly networking was one of our greatest challenges as we started. With 7 nodes at 7 different universities spread out across Australia, it was critical from the very outset that we had to improve our collaborations and build strong networks. We had 2 initiatives that we implemented to try and achieve this goal. One of them was to ensure that researchers had the opportunity to be part of more than one research theme. And the second one was that PhD students would have a co-supervisor that would be at a second node. And so our 22 research leaders have forged ahead with this challenge of building their strong networks. And 7 years on, we can see that we're getting significant internode publications through this strong network building. Of course, when we are building these networks, we can see that we're expanding the number of people that we are collaborating with. In fact, we can now boast 409 members in Fleet, up from our initial 149, which is great. This includes an increase in our associate investigators from 9 to 39, and our partner investigators like myself sit at 31. So not only have we expanded the number of people that we're collaborating with, we've also expanded the organisations that we've collaborated with too, and we've spread ourselves a little bit overseas as well. So countries like Italy, Poland, Singapore, New Zealand, Germany, China, and the United States. We all have organisations in those countries that we're collaborating with. And so with that, we're able to establish ourselves as world leaders in electronics research. I'll go back. Of course, one of the ways that we are building our capacity and building our networks is to start from the ground up. So that means training future scientists, the next generation of scientists skilled in quantum materials and semiconductor research. And to date, Fleet's really proud that we've contributed to training 123 higher degree research candidates and 120 research fellows. So it's quite an achievement over the last 7 years. Of course, when we are building capacity, we know we've got to dedicate time and resourcing. And at Fleet, we dedicated $2.8 million of strategic centre funds towards a number of competitive programs to help build our capacity. So this includes certain initiatives like seed funding grants, collaborator travel grants, Women in Fleet and Diversity in Fleet fellowships, which Julie will talk about in a little bit. We also had internships and carers grants. All of these have come together to help support our scientists and build Australia's scientific capacity. Of course, not only are we building capacity through those competitive programs, but we also have a Fleet translation program. So this is being able to translate our research, our scientific discoveries, into the devices of tomorrow. So with this, we need to partner with industrial partners to get our research, as I said, into devices of the future. One of the ways that we were doing this is through our Meet Fleet event that we held in Sydney last year. And this brought together scientists as well as industry partners from around Australia to tackle the challenge of how we were going to reduce energy consumption in electronic devices, looking at ways that we can translate our research, fundamental research, into commercially viable devices. And as you can see, and as Michael also pointed out, we've invested through this. We've invested in 10 patents and 3 spin-off companies. Of course, another event that we just recently co-hosted was the Better Futures Hackathon, which was held last month. So the Better Futures Hackathon was an event to bring teams of scientists and industry partners together to work collaboratively to find solutions to real-world problems. And I'm really pleased to say that the winning team just happened to be a team that involved fleet members and associates who designed a quantum device for early earthquake detection. Science communication is critical these days. Some would even say it's an art. To be able to describe your technical research outputs in a way that is accessible to members of the public and to politicians is really critical. And to that, we've been trying to train our scientists and our members to be self-sufficient science communicators, to write research blogs, to write news articles, to try and demonstrate the impact that their research is actually going to have on society. These blogs and news articles are all currently available up on our Fleet website. And going forwards, they're going to form a nice repository that will go up on our Fleet Legacy website. So watch this space. Fleet's also understood the importance of mentoring, and we've invested in 5 formalised mentoring programs, and every member has the opportunity to join these mentoring programs, either as a mentor or a mentee. Currently, 144 members have taken up this opportunity to talk about career pathways and career progression and career challenges. Of course, not only do we have our formalised mentoring programs, but we also have discovered that there's quite a strong community network within our centre that leads to very informal mentoring situations. And I think a lot of this comes down to our non-hierarchical structure that we've really cultivated within the centre. And I think Jeff's going to talk a little bit more about that later. Finally, we're very proud of our graduates and our early career researchers. And so we've developed the Fleet Career Tracking Program, where we're keeping track of where our early career researchers end up. And it's great to see they're all moving on to different places, including around Australia and internationally. When we touch base with our early career researchers as they've moved on, resoundingly we hear back how important these capacity building programs that we've offered them through Fleet have really aided in their scientific career development, how they've got confidence to present at large events, how they've developed networking skills that have really helped them with their scientific discoveries. So with that, I'd like to end and welcome Mitko to come and have a chat about Fleet's impact on STEM Ed.
Good morning all, I'm Mitko, a recent PhD graduate here at Fleet. Some of you will already be aware of my aggressive affiliation with all things outreach, and the ops team have been aware enough to get me to present on the topic. From the start, Fleet set ourselves some very ambitious goals surrounding outreach and impact. We wanted to build members' science communication skills and foster public engagement and participation. Alongside this, we want to raise public awareness of Fleet's mission. It's pretty hard to get people on board with future low-energy electronics technology if they have no bloody clue what it is or why it's important. To achieve these goals, Fleet used a few key strategies. Firstly, every member, no matter their position, was required to do a minimum of 20 hours of outreach every year. 75 in 1 year. Secondly, we promoted engaging, exciting, and accessible outreach. One prime example of this was our superconducting Mobius strip, which served as a fantastic visual aid and easily segged into what resistance-free technology would mean for the world at large. But also why it's so hard to achieve. It's easy to be a good icebreaker when you're at minus 200 degrees Celsius. Other examples of outreach included home science, Fleet card games, and remote outreach. Much of our outreach came through fostering relationships with the schools around Australia. One such relationship was with John Monash Science School, where we collaborated with the school to introduce a future electronics unit for Year 9 students. Part of this unit included getting our own researchers to deliver lessons on their specialist topic, which expanded our members' communication capacity as well as educating future scientists on areas of physics they'd never been exposed to. However, it also turns out that you can teach primary school kids quantum physics, with several of our outreach workshops for primary students focusing on what an atom is and how electrons work, with some catapults and Newtonian mechanics thrown in for good measure. These tangible takeaways were used to measure the impact of our outreach on students, the public, and our own members. One takeaway we consistently found with public engagement was the lack of awareness on the issue as a whole. Almost every person surveyed had little to no knowledge on the amount of electronics used in current communication technology, or the amount of energy that's wasted. We also found substantial impact on our own members, with many early career researchers saying that outreach with Fleet had had strong positive impact on their communication skills. Overall, our outreach speaks for itself. Through the past 7 years, Fleet has interacted with 45,000 members of the public and 28,000 potential future scientists through 7,500 hours of outreach, and created at least one future science communicator. To talk further about Fleet's overall impact, we have Dr. Julie Carroll, Chief Investigator here at Monash.
And so it was important for us, of course, to make scientific discoveries, but it was also important for us to innovate outside of the lab and to really try to do things differently. As you heard from Kiralee, we had a particular focus on cultivating the next generation of STEM leaders. And so we're very proud of the fact that our researchers were awarded 31 fellowships totaling $22 million. In addition, our early career researchers, 16 of our early career researchers went on to secure tenure track positions. And this is really a great outcome. And so I want to say a little bit about some of the things that we did with a particular focus on diversity and women. So we supported women to become leaders in the Australian science and technology sector. And Fleet really created an environment which enabled early career women to thrive, progress, and to develop into capable and confident leaders. This was done through a number of programs which supported women in becoming in leadership roles. And one of those programs was the Women in Leadership Australia, which 23 of our members undertook. I want to say a little bit about some of our hiring practices. So in 2018, we realized that the number of women fellows that we had was quite low. It was around 16%, and perhaps more worryingly, that number seemed to be stagnating, and we were having a really hard time getting high quality women applicants for our open positions. And so we created the Women in Fleet Fellowships. This was a combination of fellowships and PhD scholarships. And the idea was that it was for women only, any university with a Fleet node, any CI, and any background which is sort of appropriate for Fleet. And so we got 68 applicants, which is sort of a staggering number in comparison to what we were getting for our other open positions. We were able to appoint 3 fellows and an additional 2 fellows through sort of a co-funding scheme. And we awarded 17 PhD scholarships, a combination of full scholarships and top-up scholarships. What I'd really like to highlight from this program is the fact that these are the pictures of our 5 Women in Fleet Fellows. All of these women are still in science, and almost all of them have secured tenure or tenure track positions. This is really a win for Fleet, and it's a win for science. Now, in 2021, one of our PhD student members pointed out, well, actually, diversity is much broader than just gender. And so in response to that, we created the Diversity in Fleet program, where we expanded the eligibility criteria to what you can see here. And we were able to award an additional 4 fellowships as well as 4 PhD scholarships. And so this was really an impactful way to increase diversity in Fleet. I think it's important to note that this Diversity in Fleet program really came about through a PhD student feeling comfortable enough to point out something and then us responding. And that really underscores our organizational culture. And Jeff's going to talk about that now.
Right from the start, when we began Fleet, we sought to create this transformative workplace culture, which was marked by inclusivity, family-friendly policies, and a strong sense of community, with transparency and collaboration really at our core. We wanted to encourage a culture of sharing rather than competition, where everyone wanted to help each other and to achieve their goals. When we asked our members and alumni what they saw as the key strengths of Fleet, I'm very pleased to say that this culture showed through in a lot of these responses, where people commonly mentioned things such as collaborations, the people, communication, and a supportive environment as key strengths of fleet. When we asked about the effectiveness of our training, a common response was that this sense of community not only made the training more enjoyable, but also made that training more effective. Similarly, many people also responded that this fleet family provided a ready-made network of experts and expertise where people felt comfortable to ask for help or advice. This not only influenced their participation in various fleet events and also their scientific research, but also enabled them to establish the strong relationships, collaborations and networks that you've already heard have been so important to the successes of fleet. Others said that the fleet higher-ups felt accessible and not on a pedestal, which was indicative of this non-hierarchical culture that we've already been mentioned. Now, some of this may have happened organically and because of the wonderful people in fleet, but this is typically not enough, and more structured approaches are also necessary and have been necessary. For example, this non-hierarchical culture is easy to say from our leadership perspective, but to be believed, it really needs to be demonstrated in our everyday policies and actions and the way we interact. For example, having our chief investigators give posters while our early career researchers give the talks at our annual workshops has helped with this. Similarly, making sure that everybody is contributing their hours in outreach, whether that's the director and chief investigators through to our postdocs and students, has also helped create this culture where everybody's on that same sort of level and everybody feels welcome and encouraged to go and talk to anybody. We've also, as we heard from Julie, tried to create this culture where everybody feels like they can help influence the decisions and the directions of fleet. Part of this has been encouraging people to take part in our governance committees, but also being transparent in the way we run our meetings, where everybody's welcome to attend and our meetings are always published, through to having all of our data available on our fleet website so everybody can see how we're tracking with regards to our key performance indicators and our goals. Now, having this flat organisational culture is important, but it's also not enough to create this sense of community that we really wanted to create. Other things that have helped build this community include sharing and celebrating our individual stories, not just our research successes, but who we are as people. And this has been achieved through things like having our cultural dinner at our annual workshops, where we invited people to come in their cultural dress and share stories from their culture and their background. And also having our fleet humans, where we encouraged and invited people to prepare a slide on who they are as people, their background, their interests, which we were then cycling through in the breaks during our annual workshops. This helps to normalise the idea that, yes, we're all scientists, but actually we're all people first. And on this same theme, we also, as one of our key targets, wanted to create a family-friendly environment, family-friendly workplace. As part of this, for our annual workshops and at every one of our fleet conferences, we provided on-site childcare, which at the time, 7 years ago, was not very common. And I'm pleased to say more and more we're starting to see this at a lot of conferences. And by encouraging people to join in, bring their families, and then join in with our dinners and our meals and our poster sessions. And we found that the feedback on this was enormously positive, whether that was from the parents who brought their families, non-parents, our visitors, as well as our advisors. Everybody was very appreciative of this environment this created, and it clearly played a key part in creating this inclusive and welcoming environment where everyone felt comfortable. Throughout our 7 years of fleet, looking after the well-being of our members has also been a key focus. Now, when we were hit by COVID in the middle of fleet, this became even more important. And we wanted to show some leadership in how we could actually look after our people as they're facing these quite significant challenges. For example, for our PhD students who face quite significant difficulties being shut out of labs and not being able to progress their experiments and their research as rapidly as they'd like, we were able to provide write-up scholarships for at the end of their PhD, where they were able to stick around for an extra 3 months to finish those papers, which would then help them get their next job or the job after that and build their scientific CV. We also created a colloquium series involving researchers across Australia and North America, when we couldn't travel, it was then important to be able to continue and maintain these connections and interactions across the Pacific, and is then extended throughout Europe as well. And this colloquium series is continuing today. But even beyond COVID, we've also recognise the importance of being able to look after our people when they're facing various challenges, as they do throughout their research journeys. Through processes such as our mentoring and training, which you've already heard a little bit about, through to helping people identify inappropriate behaviour and deal with the problems in ways that they are comfortable with. And while there's always room for improvement, our annual surveys have consistently told us that we've been doing a pretty good job in creating this culture where everyone is starting to feel comfortable. This sense of community has not only grown from the scientific collaborations, but also helped to establish new scientific collaborations. And it's this collaborative environment that's regularly been highlighted by our alumni as one of the key strengths of Fleet. And this has benefited them not only while they're in Fleet, but in helped them build networks throughout their journey as they grow into their career and develop their own research profile and grow into leadership positions. These collaborations and networks that they've been able to establish through Fleet has stood them in good stead. Now, this doesn't happen by accident, but comes about as a result of having a community that really values everyone's contributions and where everyone is willing to help. In fact, in all the areas of impact that we've heard about today, this culture has benefited those and enabled those outcomes to be even more significant than what they might otherwise have been. So I think everybody who has been a part of Fleet can be really proud of this culture that we've helped to create. And while some of the things we've done might have posed some administrative and logistical challenges, I'm sure you'll all agree that it's been extremely well worth it. And I'll hand back now to Michael to sum up.
I hope what you've gotten in this this short time is a picture that Fleet has made an impact not only in generating knowledge and pushing forward this idea of new types of transistors and making those a reality, which we were able to do over the last 7 years. But in order to do that, we built a capacity for doing this kind of quantum materials research in Australia, which really didn't exist at this level previously. And we built that capacity, we built those networks around the world to get that research done. And we did it in a way that was diverse and equitable and inclusive. We did it in a way that we built a community that really, I think, changed the culture in the way this kind of research was done, and allowed us to really build a really vibrant community that works well together. And that is a thing that will persist well beyond the 7-year period of the center. So I think it's a fantastic thing that we have done, that Fleet has done. We, all of us, all of you in this room, have been able to do is to build that community that's doing research in a better way and has capacity to do really world-class quantum materials research, and that will continue. That's what that hopefully that gives you a good picture of Fleet. I'm going to hand back to Joanna, who is going to introduce the other speakers.
Thanks very much, Michael, and the Fleet leadership team. It's just tremendous to see the impact that you've had over the last 7 years. So thank you for sharing that journey with all of us. I'd like to introduce our next speaker now, Professor Mike Ryan. Mike is the Interim Deputy Vice Chancellor Research and Senior Vice President at Monash University. And Mike leads the overall university research agenda. He's responsible for Monash's research capacity, performance, and impact, and a variety of other research services at Monash. So Mike, it's great to have you with us today. Thank you very much.
Thank you so much, Joanna. I'd also like to acknowledge the people of the Kulin Nations on whose land we're gathered here today, and pay my respects to elders past and present. And also note that this week is National Reconciliation Week. It's an opportunity for us to learn more about the rich cultures of Aboriginal and Torres Strait Islanders, and also to acknowledge the true histories of Australia. So I encourage any of you who can go to any of the events that are currently being undertaken this week. It will be really valuable. I'm also delighted to be here with a special guest, the Professor Alison Ross, ARC Executive Director of Humanity and Creative Arts. So this really was a fabulous introduction to what Fleet has done, what it represents, and really was inspiring. So really fantastic to be here at this very special day, celebrating this incredible impact. Now, we know that the ARC Centres of Excellence are really exceptional. They take the most outstanding scientists to come together, fantastic leadership, really wonderful ideas, and brilliant partners and supporters around to really bring something and create a great nexus and a group together to really tackle some of these big challenges that we have in Australia and beyond. And this is one of them, and it's really great to have heard some of the fantastic science and technologies that is around Fleet, where it started and what it's achieved. Obviously, having a lot of money at the beginning is a great start from the ARC, 35 million, but $65 million in total funding to support the Fleet going forward. Launched 2018, really wonderful promise going forward. A little hiccup in the way around 2020, which we don't really like to talk about too much, but really phenomenal what's been achieved during that time, and with that particular big hiccup that's been there. So Fleet researchers have generated these new concepts for electronics, consuming obviously most of will consume less energy than the silicon counterparts, as Michael really worked through. And I got to hear new terms: topological transistors, exciton, polariton, and the fact that obviously dealing with light and matter. And I think that's really fantastic as well. The fact that the centre has produced 10 patents and 3 spin-off companies, that's really remarkable. And, we heard something around that liquid metal technology, really fascinating as well going forward. And then the metrics are really beautiful, this display about what's happening and what's happened from Fleet. Obviously, over 650 publications over that time, over 18,500 citations, more than 50% have that really large impact factor as well, which is really fantastic. But it's really around that technology, that really fascinating technology that hopefully will bring more sustainable ways of electronics, and importantly, that the training and communication that's come through from the centre as well. So we've heard that the work will help with continued growth of computing, including new advances like we're seeing with AI, and that's going to be in a sustainable way. And that's really going to be fabulous. But I've been part of Fleet as part of the advisory committee and seeing this, but what you can see much more strongly about, rather than just the technology, but it's the excellent collaboration and mentorship and training that's come through this particular centre. And Jeff, I was on a Centre of Excellence back in the 2000s with Jeff early on, and that centre looks very different from this particular centre and the achievements that come through there. So it's really fantastic just to see what's happened there. So we've known, obviously, that Fleet is dealing with lots of people, 20 chief investigators, 7 participating organisations around Australia, 25 partner investigators from 18 organisations also internationally. And that's really a wonderful interdisciplinary group of people coming together to tackle this. But I think what we also heard is how Fleet's nurtured the future STEM leaders through mentoring, expanding research capabilities, expertise, and networks. And Kiralee really nicely showed this. And Julie also really emphasised the importance of what Fleet's done with working with the early development and support of the careers of women and leadership, and also working on further around diversity as well, which is really fabulous. And we also heard from Mitko around the STEM education and community outreach that's been undertaken there as well. And I remember Mitko from 3-Minute Thesis last year did a fabulous job there at the last minute. So having people like Mitko talking to the students, the future students and future STEM leaders potentially, it's just fabulous to have within the centre. So congratulations with Fleet for doing that as well. At Monash, really, it's our partnerships that are really special to us. It's not just with our university partners that we're really important. It's with our industry, with business, it's NGOs, it's international governments. It's those that really come together with really great ideas and approaches that produce exceptional, responsible research with real world impact. And that's clearly evident with what's been done with Fleet. So again, congratulations again to Fleet. Congratulations to ARC for funding this and really seeing the value in Fleet as a centre of excellence. It's obviously helped place Australia at the forefront of technology, but I consider there's more that rather than just technological transformation that's being undertaken, there's new transformational ways of working with the community, working with people. It's really not just a centre of excellence, but it seems to be a culture and a community of excellence. And I think this is really going to be a long-lasting legacy of Fleet. So with that, I'd like to thank you all there, and thanks for having me.
I'd like to invite our next speaker, the guest from the ARC, to join us, Professor Alison Ross. Alison joined the ARC as the Executive Director of Humanities and Creative Arts in February 2023. And prior to that appointment, Alison held leadership roles here at Monash as the Academic Director of Research in the Office of the Deputy Vice-Chancellor of Research, and also as the Deputy Dean of Research in the Faculty of Arts at Monash. And Alison is a Professor of Philosophy. So Alison, please join us. Thank you for joining us today.
It's a real pleasure to be here this morning to recognise and celebrate the achievements of the ARC Centre of Excellence in Future Low Energy Electronics Technologies, herein known as Fleet, which is the collective noun for extraordinary researchers working in low energy transformations. Before I commence, I just wanted to acknowledge the Wurundjeri people of the Kulin Nation as the traditional custodians of the land we're meeting on, and recognise any other people or families with connections to the region. I wish to acknowledge and respect their continuing culture and the contribution they make to the life of this city and this region. I would also like to acknowledge and welcome Aboriginal and Torres Strait Islander people who may be attending today's event. I would like to acknowledge too the distinguished speakers and guests here, including Professor Batstone, Professor Mike Ryan, Professor Michael Fura, Associate Professor Kiralee Rule, Mike Oldfield, Dr. Julie Carell, and Professor Jeff Davies. I'm very pleased to be back here at Monash among friends and colleagues and to be representing the Australian Research Council today. The ARC has a proud history in supporting world-class research and innovation in Australia by our outstanding researchers. The recent passage of the Australian Research Council Amendment Bill 2024 highlights the government's commitment to and acknowledgement of the ARC's critical role in actively shaping and impacting Australia's research landscape. This legislation positions the ARC as a leader in administering funding for excellent, pure basic, strategic basic and applied research in all disciplines. The ARC supports world-class research and research-led innovation for the advancement of Australian society remains at the forefront of our strategic thinking and actions. As one of Australia's leading universities, Monash University has been awarded more than $509 million in ARC funding between 2018 and 2023. And already in 2024, more than $46 million in ARC funding has been awarded to Monash University. And as you'll know, if you ever have the privilege of working for the ARC, everybody's very focused on data points. And so there's a few of those in my remarks today. Monash University's contribution to research continues to increase both nationally and internationally as it delivers research that translates new discoveries into social, economic, and environmental outcomes. The ARC funds research of the highest standard that benefits the Australian community, identified through a highly competitive research grants process. This includes the ARC's Centres of Excellence scheme, which is a flagship part of our ARC linkage program. ARC Centres of Excellence increase collaboration between our most innovative researchers and industries that are vital to Australia, as you have demonstrated here through the extraordinary work of Fleet. And the government, through the ARC, awarded Fleet $33.4 million over 7 years under the 2017 ARC Centres of Excellence scheme. Through a highly collaborative process, your centre has produced research outcomes that address the government's National Reconstruction Fund priority areas, including value add in resources and renewables and low emissions technologies. By working towards a sustainable future for computing through energy efficient technologies, you have shaped the scientific community and industry through groundbreaking innovations, technologies, and discoveries. In just one example demonstrating your impact, you have addressed the challenge of reducing the energy used in information technology, which according to my colleagues in the ARC who've been looking through the RMS records, accounts for about 5% of electricity used on Earth. And I'm sure that number is increasing as I'm speaking. By generating new concepts for electronic devices that operate at ultra-low energy, Fleet has contributed to the continued growth of IT and advances in artificial intelligence in a sustainable way. Fleet has placed Australia at the forefront of international electronic technology and has developed the scientific foundation and intellectual property for future low-energy electronic systems. Indeed, Fleet's research successes have been recognised by the semiconductor industry in their industry roadmap as promising, and with 10 patents lodged and 3 spin-off companies formed to further develop these technologies, it's clear that these are more than promising developments. Fleet has also fostered a nurturing and encouraging research training environment, as we've heard, with 123 higher degree by research students, 90 chief partner and associate investigators, 115 postdoctoral researchers, 96 research assistants and undergraduate students, and 19 staff across the 7 years. What an amazing achievement. So I would like to finish by commending the team at Fleet for your dedication to advancing the electronics industry and the enduring impact your research will have on Australia. Thank you very much.
We've had a tremendous morning hearing from the Fleet team. We've heard from some fantastic speakers. We've heard from our Monash senior leadership team, and we've heard from the ARC leadership team. We're also very pleased today to be able to hear from Victoria's chief scientist, who's literally just walked in the door. And so no pressure, Amanda, I'm going to put you right on the stage here. Dr. Amanda Caples is Victoria's lead scientist. And this is a role that connects Victoria's science, technology, and innovation capability with business needs and with government's economic development activities. Amanda's a regular visitor here at Monash. She has many different roles that she plays within Victorian government. She's the chair of mRNA, Victoria's Scientific Advisory Group. She's the chair of the Victorian Quantum Technology Network and a non-executive director of Agriculture Victoria Services. And Amanda overall leads the development of industry and science and innovation policy in Victoria.
Thank you very much, Joanna, and good morning, everyone. And first of all, just to thank Michael and the team for the invitation to speak today, and apologies for being so late, but perfectly on time. So yeah, I was in the city this morning at a Bio-Melbourne Network breakfast to celebrate a piece of work which I think is kind of emblematic to the spirit of the ARC centres and particularly this ARC centre, which I think of all the ARC centres that I've had the good fortune to be involved with, Fleet is perhaps the one that has really excelled both in terms of the communication of science to the community as well as doing excellent science. So congratulations, Michael. You have led a wonderful team, and Monash is very proud, no doubt, as is Victorian Government, of the work that you have done. So in these times, with the advance of technology, I think we're really living in a very exciting technological time where we are seeing the impact of the development of, amongst other things, AI, which is just accelerating what was envisaged very early on in the establishment of this centre, that we need to find better ways of producing energy, but of utilisation of energy. And so the core focus of this centre for low energy electronics, the need has not been greater than it is today. So I think that, and I know that, the legacy of these sorts of ventures, because that's actually what these ARC centres are, a collaboration between academia, industry, will generate a cohort of PhD students and a cohort of researchers that have worked together around a mission that will really outlive the duration of the centre, because what you're doing is creating a future for us all through the people, the talent, the skills, the networks, the collaboration that has occurred as a consequence of this centre. So I really just wanted to leave that message. We really appreciate it. The impact that investment in these sorts of initiatives have. We have the data. So ARC would have the data, Victorian Government has the data, which shows that the long-term impact of collaborative initiatives, exceeds well beyond the term of the individual initiative. And can I just wish all the primary investigators and also the students who have come forward and been trained through this centre, and to the industry players, and I understand in every member, 145 members of this ARC centre are represented here today. That in of itself speaks volumes and is testament to the good work and the relationships that have been established through the centre. So I'm really delighted to be here, and I'll just leave it at that. Thank you.
Thank you very much, Amanda, for joining us, and we appreciate the feedback to all of us and the extensive set of collaborators through the centre. So we are close to closing our celebrations here this morning, but before we do, I'd like to invite the audience here to visit the new Fleet website, legacy.fleet.org.au. Today is the launch of this new website, and it's fantastic. It contains a number of different case studies on the centre's impact areas and the history, the 7-year timeline of the journey of the centre with key milestones. And more content will be published onto this website over the next few months. But this is the beginning of the continuation of the journey for Fleet as we look ahead to what comes next as we wrap up the Centre of Excellence. And so although the centre will soon cease the formal operations, as I think was pretty clear with today's conversations, Fleet's legacy is in the expertise and culture of the researchers that have been involved. And so the wide Fleet network will continue to collaborate and continue to develop the research through other collaborative programs and opportunities. The students and ECRs that have been trained are the future electronic and quantum workforce for Australia and globally, and will continue to contribute and make an impact in STEM. For all of you who have been involved in the Fleet Centre over the last 7 years, thank you for your contributions. And as we look ahead, we're really excited to see what comes next, and we'll be tracking the progress for all of you as you move on to the next phase of Fleet. So thank you. Thank you for all of our presenters and speakers today, for our distinguished guests, for our network of alumni and stakeholders who have joined us this morning. Thank you for attending our celebrations today. And this concludes the formalities, and we invite all our guests to enjoy the posters and science demonstrations, as well as some refreshments. Please hang around, spend time with our guests. Thank you again to the Director of Fleet and the Fleet team that have joined us here today. And congratulations to all of you for a fantastic 7 years of impact. Thank you.